plus u to the 1/2 du. Everything's in terms of u's. The things inside, in between the integral sign and the du are added together or subtracted, so we can look at them separately. We add 1 to the power. Divide by the new power, so I'm dividing by 5/2, but that's the same as multiplying by 2/5. And I can do the same thing with the u to the 1/2. I add 1 to the power. Divide by that new power. Dividing by 3/2 is the same thing as multiplying by 2/3. And I'm going to evaluate this antiderivative between u values of 0 and 1. So I'll plug in the 1 first. 2/5 times 1 to the 5/2 plus 2/3 times 1 to the 3/2. And then I'm going to subtract off plugging in 0. So we've got 2/5 times 0 to the 5/2 plus 2/3 times 0 to the 3/2.
But ain't u x minus 1?
Yeah.
Well, we
change
changed
the
the
boundaries.
value of, from 0 to 1 instead, so we can just do direct substitution.
Right, so remember how we changed these boundaries here? We changed so
Yeah.
that these guys are u values? So that means that because these are u values, I do not want to change back into my x's.
Okay.
I want to keep my u's and just plug in those new u bounds. If you change back to x's, you would change back to your original boundaries. Okay, so this is nearly our final answer. We've got 0, and so we've got 2/5 plus 2/3, and if you were super excited about that, you could combine it into one fraction. And if you're not super excited about it, then you can leave it like that. All right. Questions or comments?